This is Mastering Mathematics with your teacher, Karen Weston.
Hello Antigua Barbuda and the rest of the world. Welcome again to the dawn of the next evening, alright? And today we are going to continue where we left off yesterday. Yesterday we showed you parallel straight lines, and today we said we're going to do circles. But of course you must know this is Mastering Mathematics, and it's a program sponsored by the Ministry of Education in conjunction with its EBU unit and Center for Mathematics and Warrior Education and ABS Television. We must not forget the guys at ABS Television, because they are so excited about this show too that we have to thank them every time, all the time. And of course you know who's behind the camera. Yes, this man Jetta. But I have to tell you, Jetta is not only a cameraman, you know, he's really a co-partner with me, because when it comes to lovely, do you see how we neat these diagrams are? Do you think these would have come from Karen Weston? No. Right, Jetta and Mrs. Thompson, they can take the cake when it comes to neatness in terms of producing your diagrams here for you. So, we gave you a preview yesterday because, parents, I don't want you to tell your grade 6 or grade 4 students not to listen. Let them listen. This is how the knowledge is going to be passed on to them. Tell you all the time that when we were in N1 at the University of the West Indies, you'd hear some of our facilitators say, "What? That is what we did for final year." Let them listen, okay? Maturity in terms of knowledge, that is good for them in the technological aspect of it. You see how they master these computers, you see how they get onto the different things, and nobody's teaching them. Same thing can happen. You have them sitting and listening to information, and no, they don't have to wait until they reach a third form, a second form, or a fifth form in a school to learn these things. If they are showing the willingness and the passion, let them go with it. All right. So that is what the technology is doing for the 21st century, where we can bring these things right into your yard. And do not forget that the tablets are not just here for you to be, what people say, oh, they're just playing a lot of games on them. Let the games be mathematics, okay? Let the games be your school language that you want to. Today, it is the turn of the circle. And we have a question from the CXC examination paper, and it says, the diagram below, this is the diagram, not drawn to scale, shows a circle with center O. Center O. EBC is a tangent to the circle. And we said the angle OBA is equal to 40 degrees, and OBF is OBF is equal to 35 degrees. And it says calculate given reasons for your answer. And that is in black, which means CXC pays a lot of attention to that, okay? The measure of, and here they are, the angle EBF. So we know it's at B, we're looking for something. The angle BOA, so we know we're looking at O for something. The angle AFB, okay? And the angle OAF. So the first letter is where we start from, and we walk along as if we're doing the vector. So we're going O, then we're going A, and then we're going F. And the little angle that's formed in between that little pocket is where we're looking to see what it is. Now, how do we approach these when we're given just this information? And again, it's an examination situation, so you are prepared. You would have learned that we know for our circle, you'll be telling yourself there is a theorem for center, angle at center, and circumference. There's a theorem for that, okay? Circumference. What do we have? We have center, and we have lines, so center and a line going from the center to the circumference, and that line is called the radius. And what did they say? They gave us the word tangent. So we know there is angle with tangent, and radius. if you had to look at that figure, what are you seeing? We're seeing little triangle and big triangle. Isn't that true, Jetto?
Yes.
All right? And then we're looking and see what's the composition for the little triangle. And we see we have OB and we have OA. And what did they tell us O was? It's the center of the circle. All right? And what did we say for our definition? A line from the center to circumference is called the radius. And we have two of them, so we know we have two radii. That's the plural form of radius. And then what figure is it forming, Jetto?
Triangle.
It's forming a triangle. But what do we know about the lines OB and OA? These are the lines OB and OA.
They're both radius, radii.
Yeah, so they are now the radii of the same circle, so then they are equal. Put on your marking on it so that you can see. Don't make your figures look bland, alright? Put on the marking so that you can see. Alright, the theorem that we know, it says if we have a line from the center of the circle to the tangent, it makes an angle of 90 degrees. So that we know that the angle OBC will be equal to 90 degrees. And similarly, at the back of it, on the other side, we also know, so that this whole big angle here, from there to there, will be 90 degrees. We also know this big angle OBE, so this angle here would also be equal to 90 degrees. So we're putting in what we know. We're not even looking for what they ask us. What do we know from this side? Where we have 40 plus something must give us 90 degrees. What is that something, Jetto?
40 plus 50.
40 plus 50. So we can say the angle ABC, the little plain piece here, that is 50 degrees. Okay? And then we have this angle that is 35 up here. But we know OBE is 90 degrees. So if a little piece of it is 35 degrees, what would FBE be equal to, Jetto?
FE should be equal to 55.
55 degrees. How did he get that? No magic in this. He knows that the whole sum adds up to 90 degrees. So if a little piece is already 35, 90 minus 35, and that is where we get our 55 degrees. Over here, and then the name for it is the complement of the angle. That is 35 degrees, right? Because when we get two sets of different pieces adding up to 90 degrees, they are called complementary angles, okay? On this side over here, we had 40 degrees, so that the 90 minus the 40, and that gave us our 50 degrees. These things are fun, all right? So that is what we have there. What else can we fit in? Now, CXC gave us a 40 degree here, but look, follow us. OBA, or if you call it OAB. What figure is that? It's a triangle. And we say it's a triangle with two equal sides. So we know we have an isosceles triangle. And what do we know about an isosceles triangle, Jetto?
Two lines are equal and just as much as the both opposite angles are equal.
Right. So he says that if two lines are equal, the opposite angles are equal. And I would tell you that you would say the line joining the two equal sides houses two equal angles. Okay? So again, two equal angles. So it doesn't matter where we have an isosceles triangle, because these isosceles triangles, they like to behave badly at times now. So they can be up in the air. So it's not like when we went to school, they just tell us the base angles are equal, because they're not always going to be facing us, okay? They can be upside down. So this is the apex angle here, okay? But this angle and that angle, because this is the line that's joining the two equal sides. This is the line that's joining the two equal sides. Or if they feel to lie down on their sides, okay? And you say those two lines are equal. This is still the line joining the two equal sides, so that these angles are equal, okay? So the line joining the two equal sides houses, two equal angles. Okay? So you don't say the base angles are equal because it's not always the base. Okay? So the triangle can be turned because I saw one like that on CXC for the January paper. And I know a lot of students got caught out for that. Okay. So then here we go. Now because we have an isosceles triangle and we know one of the angles sitting on the line joining the equal side is 40 degrees. What do we know about this angle here, Jetto?
It's 40 degrees.
Is also 40 degree too. Okay? That's the partner to the other one. What do we know about the sum of the angle for a triangle?
They're equal to 180.
They're equal to 180 degree. So when we add 40 plus 40, that is already 80. So do we know the angle? Oh, what is it equal to?
100 degrees.
100 degree. Okay? How can we use this 100 degree information? Now, again, we also know the theorem. What did I say? Center and circumference. Okay, so this is the angle at the center, and we have an angle up here at the circumference. What is the theorem do we know about the angle at the center and the angle at the circumference?
The angle at the circumference is usually half
Exactly.
the amount of the angle
The
at the
angle at the circumference is equal to half the angle at the center. And we have an angle at the center that is equal to 100 degrees. So what is the angle at circumference equal to?
50 degrees.
50 degrees. Yes, Jetty, you have to answer me sharp now. May I have to go and call my little nephew Shay, because he will come and tell me their meaning. Right, that is 50 degrees. Okay, so we can say the angle at the center is twice the angle at the circumference. And we look and we say, is there anything else we can say? All right, and then no. Okay, because even if you weren't even thinking about the angle at the center, we know we are correct because you see this angle down here is 50, and then this chord here would have divided the circle into segment 1 and segment 2. And what do we say? The angle between the tangent and the chord is equal to the angle in the alternate segment. And can you see that this triangle was built on the back of the chord AB? So you look and see where is the triangle that's built on the chord of the back AB, and the angle under the house, I call it, is equal to the angle up in the temple. You know, like when you have a church, so you have what you call that peak right up there, the spire, okay? And then the spire, yes, and that is what we're saying is the 50 degree. That's not the right word, but I'm going to get the right word for it. But they have the angle where they have that bell house up right at the back, or right at the top of there, okay? So you have like your bird thing on it, the spiral or something they call it for the church, okay? So that is the 50 degree. So when you finish fitting in all that, what do? You come over here and say, what are they asking me? And they're asking me to find EBF. Let's trace it. EBF. Do we know the angle? What is it equal to? 55 degree. 55 degree. And that is just what? The complementary angle. Okay, complement. You take your time in your exam and write out your reasoning. Complementary angle, radius, and the tangent. Isn't that true? Right. And then here we go again. BOA. So what is this? BOA. And what is that equal to? And that is equal to 100 degree. Is the apex angle of isotriangle. And the isotriangle was OBA. Alright? Because we know that OB is equal to OA, which we say that they are radii. Okay? So they would understand right away what we want to say there. And then you look again for AFB. Where is that one? So this way going A, F, and B. And that is equal to 50 degree. Okay? And then this is the one, angle at circumference equal half angle at center. Alright, so we know right away what that is. And then the other one they're asking us for is OAF. Look at it. It is OA, and it is, so let's go again. OAF. Do we know that angle What is that angle equal to? That one that they're calling OAF. Did we find that angle for them, Jetto, at all?
Not yet.
So let's look again. We're going to send you a little break. We're going to bring you back because we're not going to tell you anything that's wrong and give you this little part here that they are asking you for. Okay? So we look again and say, yes, we have to fill in that little piece for you so that you want to find out what is angle. Because here it is between the arc here coming up and it is OAF. And we can tell you that we can say, oh, I sus this triangle, but we're going to take our times and show you how you're going to get that. So go on your little break and we'll be right back to give you the answer for the last part of it coming up here for this question. So you see how we do our things and we make certain that we have all our angles and then we just read them off from off the diagram. Have fun filling in the information, seeing what it is, and then fitting them into what they're asking you for. Take your little break and we'll be right back.
Carefully read over the sections of your textbook assigned by your teacher and look carefully at the sample problems. Decide if you benefit more by reading before or after the instructor covers the material.
Healthy choices. A message from the Five Islands Primary School.
Right, so you had your break, okay? And we are back because there's one more we have to show you here in terms of the angles. But I want to remind you that this is not just talking, that the things are here, okay? Mastering Mathematics, and you can go on your YouTube and we can get all of them. So don't forget. Don't say Miss Weston didn't teach so and so this time. So everything is on YouTube and Facebook already. Alright? Now let's get back here because there was one angle that we still had to tell you about. And that angle is O. Let's look at it. Trace it up. OAF. And if you're using your little beady eyes, you can see right away that we have that this is O. And if I had to draw a line here, then I could complete another triangle. Isn't that true? Two other triangles. So this one with that drawing. Now, if we do that, then OF would now become a radius of the triangle. Okay? And that is what we're using right now. So let's just take off the power from this one because we don't want this competing with us. Good. So, when we do that, what do we know? This angle down here, we got this from CXC that this is equal to 35 degrees. And as long as we have radii from the same circle, they are equal. So we also have a triangle here, OFB. So if this, the line joining the two equal sides, houses an angle of 35 degrees, we know although this big angle up here is 50 degrees, on both sides here, this little piece of it will be equal to 35 degrees. And then we are left to say 35 and what would give us 50. And once we have done the subtraction, 50 minus 35, we know that this piece would be equal to 15 degrees. And what do we see? We see that this is a base angle for the triangle OAF. And where is A sitting? It is sitting on the straight line joining the two equal sides for triangle OAF. So if one of the base angle is 15 degrees, the other one here has to be 15 degrees. So angle OAF is equal to 15 degrees. So yes, we actually completed what the children from primary school did in terms of kites, okay? And that is what is happening there. Now we weren't satisfied, so we're going to give you another circle question coming from the CXC examination paper. And this time, we're not dealing with the center of the circle. I'm going to read that question to you now and see. So when I am not around, you pick up your book, draw over the figure again, see if you can do that too, because all this is just modeling. And you can see, and from that, try to get my grades in your brains, okay? All will be well. We are here, we're going to help each other. We're not here to cut down anybody, and we don't care what people say, because we are going to make certain that the whole of Antigua is sensitized into learning mathematics. And Jet and I are having fun bringing this to you. Just leave those sour-brain people who are just trying to steal somebody's joy. Okay, here we go. The figure is on the board. Isn't it beautiful, neat and nice? Yes, the work of Jetta right here. So he's not just a passive cameraman, you know. This is an intellectual, educated mathematician in the making. Okay? So that is where he is right now. I tell him to set the camera and come around so that people can see his face, you know. But the guy just wants to stay behind camera. I don't understand them. They don't want the world to see them. Oh my gosh. He is really a clever mathematician. Okay? So one of these times we are going to get him to come to the front too, to see what is. Oh, the world is always calling us, so we have to say sorry, we're in the studio. So we are not going to be answering any phone call from here at all. So tell them to stop calling us, because we're going to just take it off. Okay? Now, this is what we're doing here. Question number 1. And what is it saying? We have to find the angle P, T, R. That's 1. We also have to find 2, and it is the angle T, P, R. And question number 3, it is the angle T, S, R. Okay, so let's read the question again now. It says, in the diagram, and it's also below, not drawn to scale, PQ. So we pick up PQ is a tangent, okay, to the circle PTS. So that angle RPQ is equal to 46 degrees, and RQP is equal to 32 degrees. Here it is. TRQ is a straight line, okay? TRQ is a straight line, so we know right away angles on straight line what they do. And then it says calculate these things that they have given us here. How are we going to start? We can use our little beady eyes and see what is. Isn't that true? 2 angles here, so we can find the third angle, because RPQ, a 3-sided figure, is always a triangle. Isn't that true? So we can go right away. It's 180 and it's minus 46 plus 32, and that is going to give me 78. Isn't that true? So that this angle here is 102, because the angles of a triangle add up to 180 degrees. Now if this is 102, then this angle here is 78 degrees, because TRQ is a straight line and the angles here. Now you have to be able to see this, that this PR is a chord, okay, and then PQ is the tangent, and we say the chord between the tangent and the angle between the chord and the tangent is equal to the angle in the alternate segment. And then I say, look at the triangle that is drawn on the back of the chord, and you see it here. So this angle is equal to this angle here, so that is 46 degrees. What do we have again? Yes, this figure here is a triangle. So we can go 180 and it is minus, so that's 14, and this is 8 and 4, that's 12. So then this will give me 4 and 10 will give you a 6, and 2 from 7 here will leave us with a 5. So this angle up here is equal to 56 degrees. Look again what I'm just using, just angles for the triangle. Isn't that true? Okay, and then what do we know? Wow, this, that. that would add up to what? 180 degree angle on a straight line. So let's go. How can we find this little piece? So it is 180, and it is minus 6 and 6 would give you 12. So that would be 5 and 5, 10. So that's 102. And then so this is equal to 78 degree. Isn't that right? Okay. Third angle there for that triangle. No, we're looking again because we're just trying to fit in the spaces. That's where we're going. And that's what we're after. Now what can we see here? Can we get this angle here at all? And what are we saying? We had counted 1, 2, 3, 4. That's a quadrilateral. It's called a cyclic quadrilateral because it's in the circle and it's touching the circle at 4 points. As long as it touches the circle at 4 points, it's called a cyclic quadrilateral. And what do we know about the cyclic quadrilateral? We know right away that the opposite angles are supplementary. So that so S then would be the opposite angle to P. So if P is equal to 56 degree, S then would be equal to 56 minus that, and then that is going to give us 124 degree. So this is 124 degree. Isn't that true? Yes? Okay. Now let us see what they're asking us to find before we start saying we can get anything else in. First one they're asking us to find is PTR. PTR. And do we have the answer? Watch us. This is where we are walking down here. And we see that that is equal to 46 degree. And we would have given them all reasons, okay? Angles in alternate segments from the chord and tangent. Okay, that's where that part is coming from. And tangent between chord and tangent. Okay, and then they ask you for TPR. And do we have it? TPR. And then we had that was equal to 56 degree. And we had said that that was the third angle of triangle. And what was that? That was TRP. And that was TPR. Okay, we can call the triangle TPR. The triangle TPR. Okay, we can call it that too. Okay, and then we have TSR. And can we get it? It is TSR. And we know right away that that is equal to 124 degree and opposite angles in cyclic quadrilateral. Okay, so then we know that angle P plus S will be equal to 180 degree. And that is all we had to find. Okay, that is all we had to find. Okay, so you see, we were able to give you 2 sets and show you the circles. Now you go on the website, get to your papers, look at them and see that you too can be great mathematicians. Learn the theorems, get in a book, ask somebody, if not, come to the center by me and I will just write up the theorems for you so you learn them. You know exactly what to do. Walk into the center, and even if you want to say, Miss Weston, you went fast, sit down and show me. I will. Okay, as long as I'm here, I will. If I'm not around, just come around the corner and look for Jetta, and he will be anxious and willing to. He's a volunteer without even realizing it, because we can do it. Okay, or go down to the taxi center and ask the taximen, because they are looking and they too want to prove their salt. So until next week, we will be coming to you again to make certain that we're tightening on things, to make certain you're ready for that CXC exam paper that comes up on the 21st of May. You have enough knowledge with which to pass. And do not forget multiple choice. Start practicing mentally to do the questions. 30 questions wrong is a lot to get wrong out of 60. So you can do it and you will do it. See you again next time. So from us here, have a good evening.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.